Welcome to another episode here at my YouTube channel. My name is Tom with the call sign Lima Bravo 6 Quebec Juliet. Okay, it's been a long time since I did any math on a dipole antenna because I want to try to make a dipole antenna that I could just dig it on the ground so no one will see it. So basically an HOA antenna that some in the United States are using, except I just want to try to use that here in this country. Or, of course, I want to experiment. So I put up a deal with another amateur to test it out, and he was intrigued by it. And he also wanted to be with on the experiment, but I took care of the building of the antenna. It's been a long time since I did any math, and I have to do some of the math in order to understand it again. So luckily I made a video about it. And yeah, so I have a one-to-one balun here that I got from a store. I believe it was from Christech, if I'm not too wrong. Or was it from Christech? I think it was. No, it was from a store called Simaru. And it's been up here for quite a long time in the box, and yeah, and let's try to do it. So I want to do this for 20 and 10 meters, so I need to make 4 arms, 2 on each side in 2 different lengths. And I've been verifying my math with Grok or AI, but I want to do it here so people can see how I was doing it. And first time I actually did it wrong, but now I understand where I messed up because it's been 2 years since I did this stuff. So a little bit excuse. So I have the formula. So wavelength equal C divided by F. So wavelength of what we are going to find, and the wavelength on dipole is divided again by 2. I'll explain that later. So C is the speed of light, which is 2.99 something, but it's good enough using 300, and then you divide it by frequency in megahertz, and now you find it. So for 20 meters, let's start there. Let's have it a little bit bigger. I might do everything wrong. I think I will fail miserably. So for 20 meter, the wavelength is though C divided by F. That is 300 divided by the frequency in megahertz. So that will be, and it's the center frequency of the 20 meter band is 14.175 megahertz, and that is equal to what? So 300 divided by 14.175 is 20.16, and then you divide that again by 2, and you divide that, so divided by 2 equal 10.85. So that's the half wavelength that we need for the dipole. Actually, in total, for the 20 meter ball on each side of the balun. So we divide that again by 2. That's 5.29. And then you have to counteract for the slowness in the cable. So you have to multiply 0.95 on that. Multiply 0.95 equal 5.02 meter. Each length of the so so in meter, so a length per half part in meter. So that should be correct. Yeah, that should be correct. Okay, so I been looking over the data that I had with Grok, and so the math is correct. I'm just using Grok to verify that I did it correct. Again, it's been a long time since I did it. It kind of looks like it's a mess. I get it. So for 10 meter, that will be pretty much the very same frequency, it's exactly the same method. So C divided by F, it's equal 300, 300 divided by 28.850. And that is, I'm sorry for the video to be a little bit long, but it's actually a little bit reference for me later when I'm going to do it. Or maybe someone else is using my video, but this video is not scripted at all. 0.850 is equal 10.93. That's the total length. And now I need to divide that in 2 again, because it's a half wave antenna. Divide by 2. And then that's 5.99. 2 equal, then divided by 2 again. That is equal 2.59 per half of the antenna that I cut. Then I have to counteract for the slowness into the cable, and that's 0.95. That should be times 0.95 and equal 2.46 meter per half length. So for 10 meter, I'm going to use red, and for 20 meter, I'm just going to use black. So I do have my balun, or balanced, unbalanced, that's what it stands for, if I'm not remembering too wrong. So I have my balun here, and I'm going to paint it black because it's a black one. So the red one is 10 meter. So that one is 2.46. So I'm gonna copy that one. That's the plan. I want to illustrate what I'm doing. And then I will have another one on the same one, and that one can be blue. That one is twice as long. Well, almost. Actually, a little bit more. Oops. Now you know the plan, and that should work. And then I can just draw a feeding cable to the radio. Okay, I know this video is 10 minutes long, but what do you guys think about it? I know it's a silly idea to dig a multi-band dipole antenna under the ground, but come on. This looks great. All right, I'm sorry for geeking out here, and I hope you liked the episode. And if you like it, thumbs up. And I do read the comments. Just please add them there. And yeah, I want to hear what you guys think. All right, have a good one. Bye bye.